Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Mathematics Syllabus D. We also call it D Maths 4024. Today, this video is all about the revision of the main concepts and formulae which are used in this syllabus. So I have a worksheet. You cannot call it worksheet. It's a formula sheet basically, and it has main concepts written on it. And we will revise this. This revision is my students revise this worksheet, this formula sheet at the very last moment. When we are done with our revision, we are done with our paper practice, and before going to the examination hall, the last thing which they will practice, they will study is this PDF. This has all the basic concepts and all the topics and their formulas. So let's start this worksheet. I have not created this worksheet. I'm not sure what is the source of this worksheet, but this is a very useful thing, courtesy to that unknown teacher who has compiled this worksheet. So let's go. Let's start today's topic. So here we have that worksheet. This is the first topic, which is about numbers. The first topic of our course, D Maths 4024, is numbers. So natural numbers, they start from 1, and they are always positive. So the natural numbers are 1, 2, 3, 4, and they go on. 0 is not included in this, and the negative numbers are not included in this. So numbers which are used for counting purposes are called natural numbers. For example, 1, 2, 3, 4. Whole numbers, in the whole number, 0 is also included, and natural numbers including the 0 are called whole numbers. So for example, 1, 0, 1, 2, 3, 4, and so on. Integers. Positive natural numbers, negative natural numbers along with 0 are called integers. Remember, integers can be negative whole numbers and positive whole numbers both. For example, you have -4, -3, -2, -1, 0, 1, 2, 3, and 4. Rational numbers are those numbers which can be represented in the form of a fraction like P by Q, and the Q is not equals to 0. This means that the denominator is not equals to 0. Numbers which are in the form of P by Q, where Q is not equal to 0, where P and Q are positive or negative, whole numbers are called rational numbers. Another definition of rational numbers is that when you convert that fraction into decimals, that fraction, in the decimal fraction, it will be a terminating decimal fraction. Terminating decimal fraction means that after the decimal, it will go 1 step, 2 step, 3 step, 4 step, and it will stop. So it's a terminating decimal fraction. There are some rational numbers. For example, if you have 0.333333, and that means that is also a rational number, because after the decimal, it is not terminating, but there is a pattern of number which is repeating. We call it non-terminating reoccurring. So like 0.666666, that's a rational number. 1 by 3 is 0.3333. So 1 by 3, although it do not terminate after the decimal, it's a non-terminating decimal fraction, but it has a certain pattern which is repeating. So that's why it's a rational number. So then we have irrational numbers. Irrational numbers are like under root square root of the 2. Pi cannot be expressed as a rational number. Such type of numbers are called as irrational numbers. Especially remember one thing, that a number, if you take a prime number and you take its square root, then it will be an irrational number. It's a very, very famous, frequently asked in O-levels paper. to write an irrational number. So take a prime number and put a square root on it, and that will be an irrational number. Actually, the irrational number is such a number which if you convert it into decimal fraction, it do not terminate in the after the decimal. It do not stop. It goes on, and there is no pattern repeated in the after the decimal. Then we call it an irrational number. And the most famous irrational number is pi, under root 2, under root 5, under root 17, any prime number, and you take a square root of that thing. So terminating decimals are those decimals which after the point, after some steps, they stop. These are the decimal numbers which stop after a certain number of decimal places. For example, 7 by 8 is 0.875, is a terminating decimal because it stops or terminates after 3 decimal places. Recurring decimals. Recurring decimals are that after decimal, a certain pattern is repeated. These are decimal numbers which keep repeating a digit or group of digits. For example, 137 divided by 259 is equal to 0.528 957 528 957 528 957. Now you see this number 5. Now you see this number. That is this number. Okay, this is repeating again and again. So this is an rational number, is a recurring decimal. The 6 digits 5, 2, 8, 9, 5, 7 repeat in this order. Recurring decimals are written with dots over the first and the last digit of the repeating digits. For example, on the 5 I will put a dot, and on the 7 I will put a dot. So this pattern will be repeated again and again. The order of operation follows the BODMAS. The rule, first of all, you solve inside the brackets, then or the power of the bracket, then you divide, you multiply. First of all, you divide, then you multiplication is first of all done. Addition and subtraction is the last things which you will do. Even numbers which are divisible by 2, for example, 2, 4, 6, and 8. The numbers whose at the end, I mean on their right side, we have 2, 0, 4, 6, 8. If a number ends at these numbers, then it's an even number. Odd numbers, which numbers are not divisible by 2, for example, 1, 3, 5, and 7. Okay, so then we have real numbers. Real numbers are made up of all possible rational and irrational numbers. Real numbers has rational and irrational both numbers. An integer is a whole number. For example, 1, 2, 4, 5, 10, 100, 1000. A prime number is divisible only by itself, by 1. 1 is not a prime number. It has only 2 factors, 1 and the number itself. Okay, so the prime numbers are those numbers which can only be divided by themselves. The first prime number, remember, it's a very important concept that the first prime number is 2. We have 2, then we have 3, then we have 5, then we have 7, then we have 11, then we have 13, then we have 17, and then we have 19, and then we have 23. So these numbers are such numbers which are only divisible by themselves. So a prime number is divisible only by itself and by 1. 1 is not a prime number. It has only 2 factors, 1 and the number itself. The exact value of rational number can be written down as the ratio of the 2 whole numbers. Remember this thing. A rational number can be written in the form of a fraction, and the denominator is never 0. The exact value of rational number can be written down as the ratio of 2 whole numbers. The exact value of an irrational number cannot be written down because, you know, after the decimal, it do not stop. And a square number is the result of multiplying a number by itself. For example, 1 square, 2 square, 1 square is 1, 2 square is 4, 3 square is 9. So 1, 4, 9, 4 square is 16, 16. So these are the square numbers. One thing is very important that remember you have to kind of memorize. I have made a video on this, and that at least first 47 prime numbers, they should be on your fingertip. A cube number is the result of multiplying a number by itself 3 times. For example, 1 raised to power 3, 2 raised to power 3, 3 raised to power 3. So 1 raised to power 3 means 1 multiply 1 multiply 1, that will be 1. 2 raised to power 3 means 2 multiply 2 multiply 2, that will be 8. 3 raised to power 3 means 3 multiply 3 multiply 3, and that will be 27. The factors of a number are the numbers which divide exactly into 2. For example, factors of 30 are 1, 2, 3, 4, 6, 12, and 18, and 36 itself is also its factor. Multiples of a number are the numbers in its times table. Okay, for example, the multiple of 6 is the table of 6, and multiple of 4 is the table of 4. So significant figure example, here we have 2064, and if I write it correct to one significant figure, here basically are 1, 2, 3, 4 significant figures. In one significant figure, it will be only the first digit, and then rest of them will be 0. Okay, here 8064, it has 4 significant figures. If you write it into 2 significant figures, then the first 2 digits, because here you can see, here you have 6, so this 0 will become 1. So 8100. 8064, in 3 significant figures, it will be the first 3 digits, and because after it is 4, so this 6 will remain as it is, so it will be 8060. This is correct to 3 significant figures. So you have 0.00508, and here we have how many significant? These zeros, they are not significant. The zeros at the start of a number, they are not significant, but the 0 which is in the between the two non-zero digits, they are significant. So here you have 1, 2, and 3 significant figures. If you want to write it into one significant figure, so this is that digit. So after this you have 0, so simply 0.05. 0.00508. If you want 2 significant figures, then these are the 2 digits, but after 0 we have 8, so this 0 will become 1. So it will be 0.00051. 2.00508. So these zeros are between the non-zero digits, so they are significant. So here we have 1, 2, 3, 4, 5, 6. There are 6 significant figures. So if you want to write it into 3 significant figures, so what I will do, these are the first 3 significant figures. So after this is 5, so this will become 1. So it will be 2.01, correct to 3 significant figure. So decimal places means after the decimal, the first digit on the right side, that is the first decimal place. And so for example, here, this number is correct up to 1, 2, 3, 4, 4 decimal places. If you want it correct up to 1 decimal place, so this is that place. So I will write, because after this is 6, so it becomes 0.1. So this is correct to 1 decimal place. So same number, if you want to write it correct to 2 decimal places, so these are these 2 digits here. This is the second decimal place. So it will be 0.06, because after this was 4. And if you want 3 decimal places, so after this is a 7, so this will become 5, 0.065. And then you have 2.0647. So this is going up to 1, 2, 3, 4 decimal places. If you want it to be 3 decimal places, rounded off to 3 decimal places, so this is the place. After 4 you have 7, so this will become 5. So you will have 2.065. This is correct to 3 decimal places. The standard form is the number in the form a multiplied 10 raised to power n is the standard form, where the a, this number a, this is always more than 1 and less than 10. And n is a positive or negative integer. The power can be positive or it can be negative. For example, 2400. I will move the decimal 1, 2, 3, 3 steps to the left. The power will become 3. So it will be 2.4 into 10 raised to power 3. You can see this number is more than 1 and less than 10. Here we have another example, 0.0035. So I will move this decimal 1, 2, and 3. So it will become 3.5, because I have moved the decimal to the right. So the power will become negative 3. Because I moved 3 steps, so the power will be -3. And 3.5, you can see this is more than 1 and less than 10. Okay, so we have here conversion factors. So the length in 1 kilometer is equals to 1000 meters. Remember this number. 1 meter, it has 100 centimeters, and in 1 centimeter there are 10 millimeters. Km means the kilometers, and m means the meter. Cm means centimeter, and mm means the millimeter, small m. Okay, so for the time, 1 hour has 60 minutes, which is equal to 3600 seconds. In 1 hour, there are 3600 seconds. In 1 minute, there are 60 seconds. In 1 day, there are 24 hours. In 1 year, there are 12 months, 52 weeks, 365.25 days. This is a very important conversion. Okay, the mass 1 kg is equals to 1000 gram. 1 gram has 1000 milligrams, and 1 ton has 1000 kg, where kg means kilogram, gm means a gram, and mgm means milligram. Volume 1 liter has 1000 centimeter cube. 1 meter cube has 1000 liter, and 1 kiloliter has 1000 liter. 1 dozen means 12. 1 dozen eggs, for example, this means 12 eggs. So 1 week has 7 days. 1 leap year has 366 days, and 1 light year is 9.46 expo 12 kilometer. 1 light year means that the distance the light travels in 1 year. That is called a light year, and that is equals to 9.46 expo. Okay, so this is the whole conversion. I hope you know this. Okay, then we have the percentage. Percentage means per 100. Here in percentage, the denominator is always 100. So it normally means out of 100, how much. To express one quantity as a percentage of another, first write the first quantity as a fraction of the second, and then multiply by 100. I can give you a very good example. For example, normally a question is that represent the profit as a percentage of cost. So that will be profit divided by the cost multiplied 100. Sometimes they say represent the profit as a percentage of sale. So then you write profit by sale multiplied 100. Profit is equals to the sale price minus the cost price. The loss is equals to the cost price minus the sale price. Profit percentage is sale price minus the cost price. The difference between them, that will give you the profit. Profit divided by the cost price multiply 100. Loss percentage is cost price minus sale price. That gives you the loss. So the loss divided by the cost price multiply 100. Where CP stands for the cost price and SP stands for the selling price. Okay, then we have simple interest. To find the interest, the simple interest is I. The simple interest I is represented with I. That is equals to PRT by 100. Where the P is the money invested or borrowed, we call it the principal amount. R is the rate of interest per annum, or whatever the unit they are using, and T is the period of time in years. If the rate is in annum, then the time period will be also in year. And the amount at the end of some time, that is equals to the principal plus the interest, where A is the amount. The compound interest is, here we get by using this formula, we always get the compounded amount. The compounded amount is equals to A is equals to P bracket start 1 plus R by 100 bracket close raised to power n, where A stands for the amount of money occurring after n years. This is the compounded amount, and P stands for the principal amount, R stands for the rate per percent per annum, and N stands for the number of the years for which the money is invested. If the rate, the time unit is years, this N will be years. If the R is per month, then the time here will be also in months. If this is semi-annually, this will be semi-annually. If this is quarterly, then its unit will be also quarterly. So these two are very important concepts. They both come in paper frequently. Frequently, they ask this question. Okay, then we have speed and distance and time. You know, the distance is equals to speed multiplied time. And this formula is only used when the speed is constant. When there is no acceleration in the body, then we use this formula. Distance is equals to speed multiplied time. Or you can remember this by a simple method, that if the speed is constant, then you can use this formula. Distance is equals to speed multiplied time. The formula for the speed will be distance divided by time. And if you want to find out the time, then the formula will become distance divided by speed. Average speed is always the total distance traveled by the total time taken. So for example, if you want to find out the average speed over a whole journey, then it will be the total distance traveled in the journey divided by the total time taken for that journey. Units of the speed are kilometer per hour and meter per second. These are the two famous units which we use. Units of the distance are kilometer and meter. Units of the time are hour and sometimes in seconds. Kilometer per hour, if you multiply it with the 5 by 18, it will be converted into the meter per second. And if you have meter per second, you multiply it with the 18 by 5, it will be converted into kilometer per hour. You can remember it by another way. If you want to convert kilometer per hour into meter per second, simply multiply it with the here you multiply it with 1000 and you divide it with 3600. Okay, so it will be converted into meter per second. If you want to convert meter per second into kilometer per hour, you multiply it with the 3600 and you divide it with the 1000 and it will be converted into kilometer per hour. If you can remember this, remember this. If you cannot remember this, you could try to remember this. If you cannot remember this, from where 3600 is coming, because in 1 hour there are 3600 seconds, and where 1000 is coming from, because in 1 kilometer there are 1000 meters. Okay, so this is a triangle, distance, speed, and time. That's the relationship between them. So if you want to find out distance, it will be speed multiplied time. If you want to find out speed, it will be distance divided by time. And if you want to find out the time, it will be distance divided by speed. This is the beauty of this triangle, if you have understood what I'm saying. Then we have algebra. Algebra is quadratic equation, the most important thing. An equation in which the highest power of the variable is 2 is called a quadratic equation. Thus, ax squared plus bx plus c equals to 0, where a, b, and c are constants and a is not 0. And is a general equation. Solving quadratic equations, we can solve quadratic equations by the method we have learned by factorization. We can solve the quadratic equation by using the quadratic formula. We can solve the quadratic equation, and by completing the square, we can solve the quadratic equation. So factorization and quadratic formula and completing the square. We can also solve the quadratic equation by the graphic method also. Solution by factorization, by factors. Consider the equation cx multiplied d equals 0, where c and d are the numbers. The product of c and d can only be 0 if either c or d or both is equals to 0. So that is when two numbers multiply with each other and their product is 0, that shows that either the first number is 0 or the second number is 0 or both of them are 0. This is a very important concept which we use in the factorization solution of the quadratic equation by the factorization. We factorize the quadratic equation, and when we get two factors, the factorization is done with the help of, for example, midterm breaking. And once we got the factors, then those two factors multiply with each other, and that is equals to 0. So either the first factor is 0 or the second factor is 0. Solution of the solution by the formula. We have this formula: x is equals to minus b plus minus under root, and under the under root we have b square minus 4ac, and the whole thing is divided by 2a, where a is the coefficient of the x square, b is the coefficient of the x, and c is the constant. And before you do this, the quadratic equation must be in the standard form. And by the standard form, I mean this. First of all, you should have x squared, and that term which has x squared. Then you should have the term which has x. Then you should have the constant, then equal, and then 0. Once the equation is in this form, then you can take the coefficient of the x squared, the coefficient of the x, and the constant. The coefficient of the x square will be a, the coefficient of the x will be b, and the constant will be c. The formula is this: minus b plus minus under root b square minus 4ac divided by 2a. Completing the square is make the coefficient of the x square a equals to positive 1. That is in our syllabus. All the completing the squares, the x square has a positive 1 coefficient. Bring the constant term, that is c, to the right side of the equation. Divide the coefficient of the x by 2 and add the square, that is b by 2 whole square, to both the sides of the equation. Factorize and simplify answer. You see, completing the square, always we get this form of the equation: x, for example, minus a, for example, whole square plus b. Okay. So in your paper, he will never use this word. He will ask you to represent the equation in this form. In your paper, they do not use this word, completing the square. They ask you to represent a quadratic equation in this form, which means to do the completing the square method. Okay. So here I'm unable to give you the example. So expansion of the algebraic expansion of the algebraic algebraic expression, for example, a bracket b plus c, that will be, this a will multiply with both the terms in this bracket, so it will become ab plus ac. A plus b whole square, that is equals to a square plus 2ab plus b square. We say square of the first term plus 2 into first term into square second term plus square of the second term. If you have a minus b whole square, that is equals to a square minus 2ab plus b square. In other words, we say square of the first term minus 2 into first term into second term plus square of the second term. A square plus b square, that is also represented as a plus b whole square minus 2ab. And give me a minute. So a square plus b square, that is equals to a plus b whole square minus 2ab. Remember this formula: a square minus b square. This is a difference of two perfect squares, or a negative between two perfect squares, and that can be written as a plus b into a minus b. Okay, factorization of the algebraic expression: a square plus 2ab plus b square. This can be written as a plus b whole square. A square minus 2ab plus b square, that can be written as a minus b whole square. A square minus b square, that can be written as a plus b a minus b. Ordering, this sign mean is equals to this sign mean is not equals to, this is greater than, this is greater than or equal to, and this crocodile mean is less than, this means is less than or equal to. Okay. Variation, direct variation, y is proportional to x. If they say it is proportional to x, so you write y proportional to x. And when you remove this proportional sign, you put equal sign here, so y is equals to kx. If they say inversely proportional, inverse variation, y is inversely proportional to x, then it is written as 1 by. Okay, so y proportional 1 by x. When you remove this proportional sign, you put an equal sign here. So y is equals to k by x. Mensuration. Pythagoras theorem, if you have right angle triangles, for all the right angle triangles, the square on the hypotenuse is equals to the sum of the square on the other two sides. So here we have opposite to the 90 degree, this is called the hypotenuse. So this side is called the hypotenuse. And in Pakistan, we say, for example, this is base, this is height. So the c square is equals to the perpendicular square plus the base square. C square will be equals to the a square plus b square. Another way of saying this is that the square of the largest side, remember this thing, the square of the largest side is equals to the sum of the squares of the two smaller sides. In a right angle triangle, the square of the largest side is equals to the sum of the squares of the two smaller sides. Sometimes they ask you, they give you three sides and they ask you to prove that this is a right angled triangle. So how you will prove that this is a right angle triangle? You will find the square of the largest side and you will find the sum of the squares of the two smaller sides. If both of them, they are equal to each other, then this is a right angled triangle. So in the same way, if your c square is less than the a square plus b square, then this is an acute angled triangle. If your c square value is greater than a square plus b square, then it is an obtuse angled triangle. So from this formula, I can find the c, that will be the square root of the a square plus b square. I can find b, its formula will be the square root of the c square minus a square. I can find the value of the a, and its formula will be c square root of the c square minus b square. So here we have area and the perimeter. So area and the perimeter, rectangle, this is the diagram of the rectangle. It has four sides and all these angles are of 90, the length, the breadth. Area is equal to the length multiply breadth, and the perimeter is 2 times length plus breadth. Square, and all the sides are equal, all the angles are of 90 degree. Area is equals to side multiply side, that is a multiply a, or perimeter is equals to 4 multiply side, that is 4a. In the parallelogram, if this parallel side is supposed as base, then the perpendicular distance between this parallel side and the other parallel side, and that is the height of the parallelogram. The area is base multiply height, and the perimeter of the parallelogram is 2 multiply a plus b, that these are the sides. Okay, area is also ab sine theta, ab sine theta, ab sine theta. Okay, and that is coming from here, this is coming from here. You see, we divide this into a triangle. You can find the area of this triangle, that will be 1/2 ab sine theta, and when you double it, then you will get the area of this parallelogram. So if you know the two sides of the parallelogram and the adjacent sides of the parallelogram, and you know the angle between them, then you can find the area of the parallelogram by this formula ab sine theta, where a and b are the sides and the theta is the included angle. The triangle, there are two formulae for finding the area of the triangle. One is 1/2 into base into height, and if you know this is the base, the height will be the perpendicular coming from the third vertex onto that side. So 1/2 into base into height, if you know this thing and the base and height, you can find the area. Or another way of finding this area is if you know the angle between, if I know this angle, I can find the area of this triangle, and the formula is 1/2 ab sine c. 1/2, if you know the length of the two sides of a triangle and you know the included angle in them, you can find the area of that triangle. The formula is 1/2 ab sine c. Both these formulae of the area of the triangle, they are frequently used in O-levels papers. Okay, another formula, this is called Hero's formula. Area of the triangle is, you know, the three sides a, b, and c. These are the sides of the triangle, and the s here is A plus B plus C divided by 2, you can say it's half of the perimeter of that triangle. Then you can find the area by this formula. Square root of, this is all is under the square root S bracket S minus A bracket close bracket start S minus B bracket close and S minus C. So this formula is rarely used, but you should remember this also. Perimeter of the triangle is you add up all the three sides. Okay, then we have a trapezium, and in the trapezium, you see the two sides are parallel to each other, and the two sides are non-parallel. And for example, these two sides are parallel to each other, and this is the perpendicular distance between these two parallel sides. And the area of the parallel trapezium is 1 by 2 into A plus B and into height. We say 1 by 2 into height of the trapezium into the sum of the parallel sides. Perimeter of the trapezium is add up all the four sides. Circle is like this shape, and this suppose from the center to the circumference. This length is called the radius. Area of the circle is pi r square. The circumference, this outer arc of the circle, its length is 2 pi r. Then we have this semicircle, and this is the radius of the semicircle. The area, because it's half the circle, so it is 1 by 2 pi r square. Its perimeter is 1 by 2 pi d plus d. You see, this is basically the arc, which will be half of the pi d, and this is the diameter. So it has a straight line and an arc. Okay, the sector is, for example, the angle subtended at the center by the sector is theta. Then the area will be pi r theta by 360 pi r square, and the length of the arc of this arc is theta by 360 2 pi r. This is a very important formula. Okay, then we have surface area and volume. So this shape is called a cylinder, a very famous this 3D diagram. This is a solid cylinder. So this is surfaces. We have this curved surface, and these are the two flat surfaces. The curved surface area is 2 pi r h, 2 pi r h, and the total surface area will be 2 pi r h plus 2 pi r square. Volume of the cylinder is pi r square h, pi r square h, where h means the length of the cylinder. Cone, this is the basic shape of the cone. This is the vertical height of the cone, and this is the radius of the base. The curved surface area of the cone is pi r l, where l is the slant height. This is called the L. This is the slant height, where the L is equals to the square root of the r square plus a square. And this is the relationship because this is a right angle triangle. So L square is equals to a square plus r square. So L will be equal to the square root of the r square plus a square. The total surface area is, the curved surface is pi rl, and the bottom is pi r square. That's why we have pi rl plus pi r square. Volume of the cone is 1 by 3 pi r square h. 1 by 3 pi r square h. The sphere, this is the shape of the sphere. It's like a football. Surface area is 4 pi r square. That's the curved surface. And the volume is 4 by 3 pi r cube. 4 by 3 pi r cube. Pyramid, and the base, its surface area is the base, the area of the base, and the area of the shape in the sides. For example, it has 4 triangles as walls. So the area of these 4 triangles and this base. Volume of the pyramid is 1 by 3 into base area into the perpendicular height. 1 by 3 into the base area into the perpendicular height. The cuboid is a rectangular box, and its surface area is 2 length and breadth plus breadth multiply height plus length multiply height. Okay, so the volume of the cuboid is length into breadth into height, and the cube is the shape whose all dimensions are same. So its length is L, its breadth is L, its height is L. Its surface area is 6L square. 6L square. Its volume is L cube. Its volume is L cube. Hemisphere is like this. Its curved surface is 2 pi r square, and this volume is 2 by 3 pi r cube. 2 by 3 pi r cube. Okay, then we have this geometry, angles on a straight line. The angles on a straight line add up to 180. So you can see this is a straight line. So these three angles, they are the adjacent angles on a straight line. So their sum will be equals to 180. So x plus y plus z will be equals to 180. Angle at a point, if you have all the angles about a point, their sum will be equals to 360. So a plus b plus c plus d, that will be equals to 360. The angles at a point add up to 360. So you have a plus b plus c plus d equals 360. So vertically opposite angles, if two straight lines intersect each other. So for example, these two straight lines, they are intersecting each other. So this angle and this angle, they are vertically opposite to each other. This angle and this angle, they are vertically opposite to each other. So A will be equals to C and the D will be equals to B. We call them vertically opposite angles. Okay. So here we have, then we have this diagram, parallel lines. For example, these are the two parallel lines. This line is cutting them. These are called, this line is called transverse line. When lines never meet, no matter how far they are extended, they are said to be parallel. So this line and this line, they are parallel. This is a transverse line. So vertically opposite angles are equal. So when you draw this line, the vertically opposite angles are A and C, they will be equal to each other. B and D, they will be equal to each other. Q and R, they are vertically opposite to each other, so they will be equal. P and S, they will be equals to each other. So A is equals to C, B is equals to D, P is equals to S, and Q is equals to R. Corresponding angles are those angles, in one is inside the parallel lines and the other one is outside the parallel lines on the same side of the transversal line. So for example, here A and Q, they are corresponding angle to each other. D and S, they are corresponding angles to each other. B and P, they are corresponding angles to each other of the parallel lines, and they will be equal to each other. C and R, they are corresponding angles of the parallel lines, and they are equal to each other. So the A will be equals to the Q, B will be equals to the P, C will be equals to the R, and the D will be equals to the S. Alternate angles are those angles which are inside the parallel lines, and one is on the right side of the transverse line and the other is on the left side of the transverse line. So for example, here the D and the P, they are alternate to each other. C and the Q, they are alternate to each other. Alternate angles are equal to each other. So the D will be equals. So here the C will be equals to the Q and the D will be equals to the P. So the sum of the angles of a triangle is 180 degrees. The sum of the angles of a quadrilateral is 360 degrees. Another very important, which is not written here, is the allied angles. The two angles which are inside the parallel lines and they are on the same side of the transverse line, they are called the interior angles, or we also call them the allied angles. So the D and the Q, they are allied angles to each other. C and the P, they are allied angles to each other. Their sum is equals to 180. D plus Q will be equals to the 180 degree because they are allied angles. C and the Q, their sum will be equals to 180 because they are allied angles. Okay, then we have types of the angles. Given an angle, if the theta is less than 90, then theta is an acute angle. So if the theta is more than 90, less than 180, then theta is an obtuse angle. If your theta is, or your angle is more than 180 and less than 360, then the theta is an reflex angle. For example, this angle here, this is a reflex angle because it is more than 180 and less than 360. And frequently in O levels, they ask you to find out, for example, this is AOB. They will ask you to find out the reflex angle AO B. So this is about the angles. Then we have triangles. We have triangles. So we have triangles. There are different types of triangles. An isosceles triangle has two sides and two angles the same. In the isosceles triangle, you see, for example, AB and the BC, their sides are equal. This angle and this angle, they are called the base angles, and they are equal to each other. This is a very important characteristic of the isosceles triangle. The angle ABC and the angle BCA, they are equal to each other. An equilateral triangle has three sides and three angles the same. In equilateral triangle, all the three sides are equal to each other. This angle and this angle and this angle, they are equal to each other. All of them are of 60 degree. A triangle in which one angle is a right angle is called a right angled triangle. For example, if this angle is 90, so then this is a right angled triangle. Okay. So then we have angle properties of the triangle. The sum of the angles of a triangle is equals to 180 degree. If you add up all the three internal angles of a triangle, the sum will be equal to 180 degree. In every triangle, the greatest angle is opposite to the longest side. The smallest angle is opposite to the shortest side. Exterior angle is equals to the sum of the opposite interior angle. For example, if you extend one of the sides, then the angle between that extended and the adjacent side, that is external angle, that will be always equals to the sum of the opposite internal angle. X will be equals to the A plus B. Then we have congruent triangles. The two triangles are said to be congruent if they are equal in every aspect. All their three sides are equal to each other, and all their three angles, they are equal to each other. Here, the AB side will be equal to the XY side, BC side will be equal to the YZ side, the AC side will be equal to the XZ side. The angle A will be equal to the angle X, angle B will be equal to the angle Y, angle C will be equal to the angle Z. The similar triangles, if two triangles are similar, then they have a pair of corresponding equal angles, and the three ratios of corresponding sides are equal. So that means that the angle A will be equal to the angle X, the angle B will be equal to the angle Y, the angle C will be equal to the angle Z. But the sides are not equal, they are in a certain ratio. For example, the AB divided by the XY and the BC divided by the YZ and the AC divided by the XZ, the answer, the ratio will be the same. Okay, that's the characteristic of the similar triangle. If you can show that one of the following condition is true for two triangles, then the two triangles are similar. How you prove that the two triangles are similar? One test is that you prove that the two angles are same. If you are comparing two triangles, and in those two triangles, if the two angles are same, then those two triangles are similar to each other. The angles of one triangle are equal to the corresponding angles of the other triangle. A triangle ABC is similar to triangle XYZ because the angle A is equal to the angle X, and the angle B is equal to the angle Y, and the angle C is equal to the angle Z. And another way of proving that the two triangles are similar to each other, you prove that the ratio of their corresponding sides, that is, the ratio is same. So PQ, if you the ratio of the PQ to the ratio of the DE, and the ratio of the PR to the DF, and the ratio of the QR to the EF, if these three ratios are same, then you can prove that the triangle PQR is similar to the triangle, DEF. Okay. So then we have third is the ratio of the corresponding sides are equal and the angle between them are equal. If the ratio of the two corresponding sides is same and the included angle is also same. So a triangle PQR is similar to triangle XYZ if, for example, angle P is equals to angle X and the PQ divided by the XY is equals to the PR divided by the XZ. So areas of the similar triangle, if the two triangles are similar, then the ratio of their areas is equals to the square of the ratio of their sides, their corresponding sides. The ratio of the areas of similar triangles equals to the ratio of the square or on corresponding sides. For example, here we have two triangles, they are similar to each other. So the area of the triangle ABC divided by the area of the triangle PQR, that will be equals to the ratio of their corresponding side, its square. So AB square divided by PQ square, or that will be equals to the BC square divided by the QR square, or that will be equals to the AC square divided by the PR square. We also say area 1 by area 2 is equals to the length 1 by length 2 whole square. Polygons, exterior angle of a polygon add up to 360. No matter how many sides are in a polygon, the sum of the external angles of a polygon is always 360. The sum of the interior angles of a polygon can be calculated by this formula, that is n minus 2 multiply 180, where n is the number of the sides of the polygon. A regular polygon, when we use this word regular polygon, that means all the sides are same and all the angles are also same. A regular polygon has equal sides and equal angles. If the polygon is regular and has n sides, then each exterior angle is, this is only for regular polygons, each external angle will be 360 divided by n. Three-sided figure is called a triangle. The four-sided figure is called a quadrilateral. Five-sided figure is called a pentagon. Six-sided figure is called a hexagon. Seven-sided figure is called a heptagon. Eight-sided figure is called an octagon. Nine-sided figure is called a nonagon. And 10-sided figure is called a decagon. So similar solid, if two objects are similar and the ratio of the corresponding side is k, then the ratio of their area is k square and the ratio of their volumes is k cube. So the ratio between for the similar solids, the ratio of the length, width and height, radius, circumference, depth and diameter, that remains the same. L1 by equals to R1 by R2 equals to H1 by H2. The ratio of the areas for the similar solids, area 1 by area 2 is the square of the ratio of their sides. So area 1 by area 2 can be R1 by R2 whole square, or it can be H1 by H2 whole square. For volume and for mass and for the capacity, remember these three words: volume, mass, capacity. The ratio of the volume 1 by volume 2, that will be equals to the cube of the ratio of the sides. For example, R1 cube divided by R2 cube, or it can be height 1 cube divided by the height 2 cube. So these are the solids, and this is a formula applicable. These are similar solids, okay? Okay, then we have circles, and in the circle, this is a very important thing. The angle subtended by an arc at the center is twice the angle subtended by the at the circumference. For example, this arc subtends this angle at the center, and this arc subtends this angle at the circumference. If this is P, this will be 2P. Angle at the center is 2 times angle at the circumference. For example, this arc, if you go to the center and the same arc goes to the circumference, the angle at the center will be 2 times angle at the circumference. For example, this arc and goes to the circumference, the angle is P, it comes to the center, the angle is 2P. This is P, this is 2P, angle at the center is 2 times angle at the circumference. For example, this arc goes to the center, the angle is 2P. If this arc goes to the circumference, the angle will be P. Angle at the center is 2 times angle at the circumference. The angle subtended by an arc in the same segment of a circle are equal. For example, if you are talking about this arc and I join these 2 points, then this is one segment and this is the other segment. if you take this to the same segment, if you take the points of that arc to the circumference in the same segment, all these will be equals to same. They, all these angles will be equal to each other. This is called the angles in the same segment. The angles in a semicircle is a right angle. For example, this is a circle, this is the diameter. If you take the ends of the diameter to the circumference, the angle at the circumference will be always 90 degrees. This is the diameter, okay? So we call this right angle in the semicircle. The angle in a semicircle is a right angle, or if a triangle is inscribed in a semicircle, the angle opposite the diameter is a right angle. Angle APB will be 90 degree. So this is a cyclic quadrilateral. Cyclic quadrilateral is a quadrilateral whose four corners are on the circumference. If you have a quadrilateral which is cyclic, which means its vertices are on the circumference, all its vertices are on the circumference, then the opposite angles in this cyclic quadrilateral, they are supplementary to each other, which means their sum of their angles is equals to 180. So this angle B and angle D, their sum will be equals to 180. Angle A and angle C, their sum will be equals to 180. This is called the angles in the opposite segment are supplementary. We call it angles in the opposite segment, they are supplementary. Opposite angles of a cyclic quadrilateral add up to 180, or they are supplementary. The corners touch the circle. A plus C is equals to 180 degree and B plus D equals to 180 degree. The exterior angles of a cyclic quadrilateral is equals to the interior opposite angle, okay? So for example, this is the cyclic quadrilateral and you extended its one side. The angle between this extended side and the adjacent side of the quadrilateral, that is the external angle, and that will be equals to this angle, opposite interior angle, okay? So this angle will be equals to this angle, okay? Remember this thing. Chord of a circle. A line joining 2 points on a circle is called a chord. The area of a circle cut off by chord is called a segment. So this is a segment and this is another segment. This is a major segment, this is a minor segment. The area of a circle cut off by the chord is called a segment. AXB is the minor arc and the AYB is the major arc. The line from the center of a circle to the midpoint of a chord bisect the chord at right angle. So the line from the center of a circle to the midpoint of a chord bisect the angle subtended by the chord at the center of the circle. Okay, then here we have the tangent to a circle. Tangent is always perpendicular to the radius at the point of tangency. The angle between a tangent and the radius drawn to the point of contact is 90 degree. So this angle ABO is 90 degree. From any point outside a circle, two tangents to the circle may be drawn and they are equal length. If you have the tangents coming on the same circle from the same external point, they are always equals to each other in length. So the TA length and the TB length, they will be equal to each other. Alternate segment theorem is that you have a triangle whose three vertices are on the circumference and one of this vertex is on the point of tangency. Then the angle between the tangent and one of the sides of this triangle, that will be equals to the opposite internal angle. So the angle between a tangent and a chord through the point of contact is equals to the angle subtended by the chord in the alternate segment, So this angle at this angle here will be equals to this angle here. Okay, just remember that. So here we have, here he says TC square is equals to AC multiply, this is the C point, okay? So the AC multiply BC. So that will be the TC square, okay? So this property I have never seen being used here. So indices, in the indices, remember, if two numbers will be multiplying each other there and the base is same, the powers will be added. If the bases are same and they are dividing, then the powers will be subtracted. If you have a power on a power, both of the powers will multiply with each other. If any number has a power 0, that the whole thing will be equals to 1. If a number has a power minus negative power, then you can write it as 1 by a n. For example, a raised to power minus n, that will be equals to 1 divided by a raised to power n. So a multiply b raised to power m, this power is for both of them. So it will be am multiply bm. Okay, then we have these rules. Here we have, if two numbers are dividing and you have a power on them, that power is for both of them. So it will be a raised to power m, b raised to power m. If you have a radical sign, for example, nth root, and then you have a power, this can be written as m a raised to power m divided by n. The nth root means power raised to power 1 by n. If two numbers are multiplying and they both have the same radical sign, they can be written under a single radical sign and they still be multiplying. If two numbers are dividing and they are under the same radical sign, they can be written as radical a divided by, this sign is called radical, square root of a divided by the square root of the b. You can separate it. If you have a square root and you take square, it's square, then that square root will be gone and you will have only a. So this is how this is done. These are the some basic properties of the indices. They are very, very important. And in paper 1, paper 2, both papers, they ask you question on the base of the indices. Then we have solving inequality. When we multiply or divide by a negative number, the inequality is reversed. For example, 4 is greater than minus 2. If you multiply by minus 2, so you are multiplying both sides with a negative number. If you do this, the sign of the inequality, that crocodile mouth, that will reverse. Okay, so when you multiply both sides with the minus 2, for example, it will become minus 8 less than 4. You see, when you multiply with a negative number, the radical sign, the crocodile sign or the inequality sign has, you can say, reversed. Trigonometry, let ABC be a right angle triangle, and where the, okay, let ABC be a right angle triangle where the angle B is 90 degree. So sine theta is the opposite side divided by the hypotenuse. We call it O divided by H. And cos theta will be the adjacent side divided by the hypotenuse, that is called A by H. And the tan theta will be equals to the opposite side divided by the adjacent side, and that is equals to O divided by H. How you can remember this? SOHCAHTOA. SOHCAHTOA. Okay, so if this is the angle you are considering, then this will be the opposite side and this will be the adjacent side, and the side opposite to the 90 degree, that is always called the hypotenuse. Okay, the sine rule is very simple. It's a relationship between the sides and the opposite angles. So A, this side A divided by the sine A, B divided by the sine B, and C divided by the sine C. Okay, this is A by sine A equals to B by sine B equals to C by sine C. This is called the sine rule. On the same figure, we can apply the cosine rule, and the cosine rule is a relationship between these three sides and the angle. For example, if I want to find out this side, and I know this side and this side and the angle between them, then the formula will be a square is equals to b square plus c square minus 2bc cos a. For example, if you want to find out this side, then I will use these two sides and the angle between them. Then the b square will be equals to a square plus c square minus 2ac cos b. For example, if you want to find out the seats, and I know that this side and the angle between them, then according to the cosine rule, c square will be equals to a square plus b square minus 2ab cos c. Okay, so the cosine rule and this shape of the cosine rule is used to find the side. If you know the three sides of a triangle, you can find any of its angle. And for that purpose, we use the law of cosine rule. And for finding the angle, we use this shape. For example, if you want to find out this angle, for example, you want to, then I should know this side, and the opposite side. So the cos of A will be equals to B square plus C square minus A square and divided by 2BC. If, for example, you want to find out this angle, then I should know this side, and the opposite side. Then the cos B will be equal to A square plus C square minus B square divided by 2AC. For example, if you want to find out this angle, I should know the angles, I should know the length of both its arms and the opposite side. Then the cos C will be equals to A square plus B square minus C square divided by 2AB. You see the law of cosine rule. This shape of the cosine rule is used to find the side. It is used to find the side of a triangle, and this shape of the cosine rule is used to find the angle of the any angle of the triangle, if you know the three sides of the triangle. So then we have the bearing. The bearing is you see what is the bearing? The bearing of a point B from another point A is an angle measured from the north at the A in a clockwise direction. So if the bearing of the B from the A means that on the A draw north, and from that north go clockwise to the AB line, whatever is the angle formed, that is the bearing. It is very important you go clockwise. Okay, written as three figures from 0, 0, 0 to 360 degrees. The bearing of the B from the A is 050 degree. So here we have distance and the gradient. If you know the coordinates of the 2 points, you can find the gradient, you can find the distance between them, and the formula for the distance is x1 minus x2 whole square plus y. Here we have, this is y1 minus y2 whole square. Remember, x1 minus x2 whole square plus y1 minus y2 whole square, and we have a square root on it. This is called the distance between 2 points. And the gradient of the 2 points, the line joining the 2 points, you can find the gradient, and the formula is y2 minus y1 divided by x2 minus x1. And the gradient of the line can also be y-intercept divided by the negative of the y-intercept divided by the x-intercept. Okay. So then we have this is okay. So parallel lines. Okay, so we have parallel lines, and these are the perpendicular lines. If two lines are parallel to each other, both their gradient, the gradient of the, for example, line 1 and line 2, they are parallel to each other, then their gradients will be equals to each other. M1 will be equals to M2. If the two lines are perpendicular to each other, then the product of their gradients will be equals to -1. For example, line 1, its gradient is M1. For example, the line 2, its gradient is M2. Then the product of their gradients, M1 multiply M2, that will be equals to -1. So here it's a very important characteristic. Okay. So midpoint, if you know the 2 points and you can find the coordinates of their midpoint, the midpoint coordinates can be found by x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. A point dividing a segment of a line, we can find out, for example, here we have a point P, and it is dividing this line segment A and B in the M ratio N. So you can find the coordinates of the P, that will be equals to nx1 plus mx2 divided by m plus n, and ny1 plus my2 divided by m plus n. A very important formula, but in O levels we have not that. This is not used that much. I have not seen it being used, but it's a very important formula. So then we have here Cartesian coordinates, and the gradient and equation of a straight line. The gradient of a straight line joining any two given points A and B is the gradient of a line. If you know the 2 points on that line, is y2 minus y1 divided by x2 minus x1, and the gradient divided by the intercept gradient or intercept form of the equation of a straight line is y equals to mx plus c. Y equals to mx plus c, where m is the gradient of that line and the c is the intercept of, for example, this line here, the m is the gradient and c is the intercept on the y-axis. And intercept of the y-axis means that when it cuts the y-axis, what is the value of the y there? Okay, so we can have here we have the midpoint of the line joining 2 points A x1 y1 and the B, which is x2 y2, is x1 plus x2 the whole thing divided by 2 comma y1 plus y2 the whole thing divided by 2. Finding the midpoint is very important. Okay, the distance between the 2 points A and B is x2 minus x1 whole square plus y2 minus y1 whole square and a square root on it. Parallel lines have the same gradient. In a graph, the gradient is vertical height divided by the horizontal height, and we say rise divided by run, rise divided by run, so or y divided by x. Okay, in our distance time graph, for example, this is a distance time graph from O to A, uniform speed, from B to C, uniform speed, from A to B, stationary, because when the distance time graph becomes horizontal, that means the body is not moving. The gradient of the graph of a distance time graph gives the speed. The gradient of this graph gives you the speed of the moving body. The speed time graph, if you have speed here and time here, from O to A, we have uniform speed because the from O to A, we have uniform, not speed. Here we have uniform acceleration. Okay, from A to B, we have constant speed and the acceleration is 0. From B to C, we have uniform deceleration, or we call it retardation. Here, the speed is gradually decreasing. That's why we call it retardation or deceleration. And here, the speed is increasing with a uniform rate, which we call it acceleration. Okay, the retardation, the gradient is 0. The area under a speed time graph represents the distance traveled. This area, which is under the speed time graph, this area is equals to the distance traveled. The gradient of the graph is acceleration. If the acceleration is negative, it is called deceleration or retardation. The moving body is slowing down. If the speed is, for example, here the speed is gradually decreasing, this is retardation. Okay, so I have corrected this word. This word is here acceleration. Okay, if this is a straight line, then it means it's a uniform acceleration in the speed time graph. Velocity is the rate of change of displacement with respect to the time. Okay, or in mathematics, because we are in mathematics, this word is distance used, but in physics it is displacement. Acceleration is the rate of change of the velocity with respect to time. Then we have set. This is the symbol for the universal set. This is the symbol for all the union, which means you take all the elements of, for example, if you're taking A union B, you take all the members of A and B, but do not repeat the member. This sign is for the intersection, and that means the common element. Here we only take that part which is common, or the overlapping part in the two sets. This set is called phi, or this is empty set, or we call it the null set. Here, this symbol means belongs to. This symbol means does not belong to. This symbol means subset. A, and you have a prime on it. A prime means a complement of A. The elements of the universal set minus the elements of A. This small n means how many members are, the number of elements in A. De Morgan's law says that the A union B whole complement is equals to the A complement intersection B complement, and A intersection B whole complement is equals to the A complement union B complement. These equations are used, but this name is not used in O levels. But in other courses, we properly use this name, De Morgan's law. Okay, then we have the subset. This symbol is for the subset. B is the subset of A, means every element of the set B is also an element of the set A. On the Venn diagram, this is represented like this. Okay, so if A and B are equal, then we will only show a single a single circle, because A and B are equal to each other and they are subset. This symbol, if you have only this symbol, this means every element of B is an element of the set A, but B is not equals to A. This is called proper subset. This is called improper subset. Okay, so if B is actually less than, if the B is, all the members of the B are in A, but B is smaller than A, then we use this symbol. This means proper subset. Okay, so this is disjoint sets. Disjoint sets are those sets which have nothing common in them. Disjoint sets do not have any element in common. If A and B are disjoint sets, then A intersection B is empty set, means there is nothing common, there is nothing overlapping between A and B. A intersection B is the set of elements which are in A and also in B. A intersection B is represented like this. This is the shaded portion which is overlapping. Intersection means the common portion. In the union, A union B, we take A and B both. They are shaded like this. Okay. In the complement means, for example, here we have set A, then the A complement will mean that the set, the elements which are out of A, means other than A. So other than A. Locus and construction. The locus of a point is a set of points satisfying a given set of conditions. Locus of points at a distance x from a given point O. If your distance from a point is constant, you always draw a circle. For example, if I say my distance from A is 4 centimeter, then I will draw a circle of 4 centimeter around A. The circumference of a circle, center O, radius x. Locus of a point at distance x from a straight line. If you have to draw, you have to remain at a constant distance, from a line, then you draw a line parallel to that line. And the method is very simple. For example, somebody asks you that I always remain 2 centimeter from AB line. So what you will do at A, you will draw a circle of radius 2 centimeter. At B, draw a circle of radius 2 centimeter and draw tangent. Automatically, those tangents will be parallel to the AB line and they will be always at 2 centimeter from AB. A pair of parallel lines to the given line AB. Locus of a point equidistant between 2 points. If you are equidistant between 2 points, then you always draw a perpendicular bisector of that line. So when you move on the perpendicular bisector, if you go anywhere on that line, perpendicular bisector, I mean, your distance from A and your distance from the B remains same. Okay, so how you draw the perpendicular bisector? You open your compass. For example, if you want to draw the perpendicular bisector of AB, you open your compass more than half of the AB. You put it on A, put an arc on one side and put an arc on the other side of the line. Then you put your compass on B and you you draw an arc on one side, you draw an arc on the other side of the line AB, where this is the point of intersection of the arcs, this is the point of intersection of arc. You join them, that is the perpendicular bisector of the 2 points or of a line. Then we have the locus of points equidistant from two given lines AB and AC. If you are equidistant, you are supposed to remain equidistant from two lines which are intersecting, then we draw angle bisector. And for example, this angles BAC. So you put your compass on A, you draw an arc on one arm, you draw an arc on the other arm. Then from here, you draw arc between the angle, and put your compass here and draw an arc in the angle, means in both inside that angle. So where these arcs intersect, you join it with this vertex, and automatically you will get a line which will divide this angle into two equal angles. This is called the angle bisector. So when you go on this angle bisector, your distance from the AC line and the AB line always remains same. Then we have vectors. A vector quantity has both magnitude and direction. Vectors A and B represented by the line segment can be added using the parallelogram rule or the nose to tail method. Scalar quantity has a magnitude but no direction. Ordinary numbers are scalars. The negative sign reverses the direction of the vector. The results of A minus B is A plus minus B. That is, subtracting B is equivalent to adding the negative of the B. Addition and subtraction of the vectors. So for example, if you want to add OA and the AC, you can use the triangular law. If you want to use the triangular law, so what you do, you draw OA, and on the head of this vector, you draw the tail of the second vector. And for example, this is the C, and then you join the tail of the first vector with the head of the last vector, and that is your resultant. This is triangular method. If you want to use the parallelogram method, law method, for adding up these two vectors, then the method is a little different. What you do, the two vectors you want to add up, for example, vector OA and the OAC, then you draw that vector in such a way that their tails are joined, and then you suppose that these are the adjacent sides of a parallelogram, and then you complete that parallelogram. When you have completed that parallelogram, then join where the tails were joined with the opposite corner of that parallelogram, and that will be your resultant. Okay, this is called the parallelogram law. This is how the vectors are added. In the triangular law, OA plus AC will be equals to OC. OB plus OA will be equals to this. Okay, OC. Column vector. The top number is the horizontal component. The top number is X, and the bottom number is the vertical component. This is called the column vector. Parallel vectors. The vectors are parallel if they have the same direction. Both components of one vector must be in the same ratio to the corresponding components of the parallel vector. In general, the vector K times AB is parallel to AB. If the basic column vector is same, here you have 2, here you have 3, here you have 4, here you have 1 by 4, then you can say they are parallel to each other. For example, if you have two vectors, and for example, I just want to explain you this sentence. For example, one vector is A and B, and the other vector is, for example, C and D, and they are parallel to each other. Then the ratio of their X will be equals to the ratio of their y. Okay. Modulus of a vector, or we call it the magnitude of a vector, and that is, for example, if you have a vector x whose column vector is mn, then the magnitude or the length of the vector, that is equals to the square root of the m square plus the n square. It is represented with like this. The modulus of vector A is written as this and represents the length or magnitude of the vector. In general, if the x is equals to mn, then the modulus of the x or the length of the vector will be m square plus n square. Then we have the matrices addition and subtraction. Matrices of the same order are added or subtracted by adding or subtracting the corresponding elements in each matrix. So A will be added with the P, B will be added with the Q, C will be added with the T, D will be added with the S. Same we do with the subtraction. From A, the P will be subtracted. From B, the Q will be subtracted. From C, the R will be subtracted. And from the D, the S will be subtracted. Multiplication by a number. If a number will multiply with the matrix, it will multiply with all the members, elements of that matrix. So if this K is multiplying with this matrix, it will multiply with the A, it will multiply with the B, it will multiply with the C, it will multiply with the D. When you multiply two matrices with each other, from the first matrix, we take the row. From the second matrix, we take the column. The first members will multiply with the first. The second member will multiply with the second. Okay, so then this row will multiply with this column. And then you are done with this. Then we do this second row. Second row do the same thing. So here we will have AP plus BR. Then we will have AQ plus BS. Then this row will multiply CP plus DR. Then you will CQ plus DS. This is how the multiplication is done. In matrices, A square means A multiply A. So you actually multiply the matrix A with the matrix A. Do not simply take the square of its elements. Don't do that. If you want to multiply A, then for example, if you have a matrix A, which is, let's say, 3, 2, 4, and 5. For example, if you want to find its square, you will have to actually multiply the A with A itself. Properly multiply like this, okay? Then you will have A square. Okay, then we have here the inverse of a matrix. If you want to find the inverse of a matrix, so that is equals to, first of all, we have to, the formula is 1 by A determinant into the adjoint of the A. Okay, so for that purpose, here we have A, B, C, D. How you find the determinant? First of all, you multiply these two with each other, then minus, then you multiply these two with each other. So this is how you find the determinant, 1 by determinant. And then how you find that adjoint, you change the position of these two with each other, and you change the sign of these two. That is the adjoint. Okay, so A, if you multiply A with the A inverse or A inverse with the A matrix, you will get I, where I is the identity matrix. And identity matrix in a 2 by 2 matrix, the identity matrix is 1, 0, 0, 1. This is called the identity matrix. Okay, and if the identity matrix multiply with any matrix, the answer is always that matrix. The number AD minus BC is called the determinant of the matrix and is written as A. We write it like this. This is the determinant. And if A determinant is 0, then the matrix has no inverse. Multiplying the inverse of a matrix gives the same result as dividing by the matrix. For example, AB is equal to C. Then A inverse multiply A, B will be equals to A inverse multiply C. So B is equals to A inverse C. If C is equals to X, Y, and D is equal to RS, then C plus D is, you add up the corresponding members. Okay, so it will be X plus R divided by Y plus S. Transformation, reflection. When describing a reflection, the position of the mirror line is essential. And if you have image and object, they both are given, you join the same points of the object and the image, and you draw the perpendicular bisector, and that is the line of reflection. Rotation, to describe a rotation, the center of rotation and the angle of rotation and the direction of the rotation are required. A clockwise rotation is negative and an anti-clockwise rotation is positive. Angle, direction of rotation about the center. Okay, so if you have the image and the object both given in a rotation, and you want to find out the center of the rotation, you join the same points, corresponding points of the object and the image, and you draw the perpendicular bisector of that line. You do it with the 2 or 3 corresponding points in the object and the image, and where those perpendicular bisectors intersect each other, that will be your center of rotation. In the translation, when describing a translation, it is necessary to give the translation vector as x and y. Here, the positive x represents the movement to the right, negative x represents the movement to the left, and the positive y represents the movement to the top, negative y represents the movement to the bottom. Translation, this is called the translation matrix, and the translation matrix is equals to the object minus the image. Sorry. Translation matrix is equals to, if you have to find out, that is equals to image minus the object. The image should be represented in a column vector, and the object should also be represented in a column vector. Here we take only one point, that coordinates 1 point coordinate. Only 1 point, its coordinates are taken here. In the enlargement, to describe an enlargement state, the scale factor K, the center of enlargement, the invariant point, scale factor is the length of the image divided by the length of the object. Enlargement by the scale factor, you see, if the scale factor is positive, both the object and the image lies on the same side of the center of the enlargement. If the K is negative, means if the K is less than 0, the object and the image lie on the opposite sides of the center of enlargement. If the scale factor lies between 0 and 1, then the resulting image is smaller than the object. Although the image is smaller than the object, the transformation is still known as enlargement. Area of the image is equals to K square, the area of the object. Repeated transformation, here, for example, if they say xt of the p, means perform transformation p on p and then perform x on the image. xp means may be written as x square p. If you have to do the same transformation 2 times, then that is represented with the x square of the p. Inverse transformation. The inverse of a transformation is transformation which takes the image back to the object. If the translation T has a vector this, then the translation which has the opposite effect has the vector minus x minus y. This is written as T raised to power minus 1. The rotation R denotes 90-degree clockwise rotation about 0, 0. Then the R inverse, R raised to power minus 1 denotes 90-degree anti-clockwise rotation about the 0, 0. For all reflections, the inverse is the same reflection. Okay. For reflection, the inverse means the same thing. Base vectors. The base vectors are considered as 1, and that is 1, 0. And the J is, this is basically written I. This is called I. 0, 1. And the column of a matrix gives us the image of, the columns of a matrix give us the images of I and J after the transformation. Shear is the, this has been removed from O-levels course, but let me tell you, distance a point moves due to the shear divided by the perpendicular distance of the point from the fixed line. For example, if you have, for example, this is the invariant line, and this is the distance of that thing. and this much, this has point has moved. Now this is the image. So the shear factor will be the distance moved parallel to the invariant line divided by its perpendicular distance from the B. The shear factor will be the same calculated from any point on the object with the exception of those on the invariant line. The points which are on the invariant line, their image is not formed. Area of the image is equal to the area of the object. In the shear, the area remains the same. In the stretch, to describe a stretch, this has been removed from the Cambridge exam, from the syllabus of the DMAS 4024. But let me tell you a little bit about this. To describe a stretch, state the stretch factor P, the invariant line, the direction of the stretch, always perpendicular. You move perpendicular. For example, this is the invariant line. Then you move perpendicular to the invariant line. Scale factor is the perpendicular distance of the C from the AB, C prime from the AB, and perpendicular distance of the C from the AB, where P is the stretch factor. Area of the image is equal to P times the area of the object. This has been the shear and the stretch, they both have been removed from the syllabus. Okay. Transformation matrices. Some students, they kind of remember this thing. If you can do that, just remember them. In my papers, whenever I have solved the papers, I have shown you the trick how to find out these matrices. We don't actually have to remember them, but if you can remember them, remember them. Reflection in the x-axis, this is represented with this matrix 1, 0, 0, -1. Reflection in the y-axis is represented with the -1, 0, 0, 1. Reflection in the line y equals to x, that is represented with a 0, 1, 1, 0. Reflection in the line y equals to -x is represented with a 0, -1, -1, 0. If you can remember it, please remember it, because in the exam, this is frequently asked. They ask you, okay, this transformation is represented with which matrix? Okay. Okay, so this was about the reflection. Then we have the rotation. The 90-degree rotation anti-clockwise about the origin, that is represented with 0, -1, 1, 0. 90-degree rotation about clockwise about the origin, that is 0, 1, -1, 0. And 180-degree clockwise, anti-clockwise. 180-degree does not matter, clockwise, anti-clockwise. About the origin is -1, 0, 0, -1. If the enlargement here is represented with a K0K, Cook, we call it K0, 0K, where K is the scale factor and the center of the enlargement is origin. For the stretch has been removed from your syllabus, but for just the sake of the video, I am just explaining to you. If you have the stretch factor K, invariant line is y-axis, and you will move obviously parallel to the x-axis. So it will be the K001. If the stretch factor is K, invariant line is x-axis, and you move parallel to the y-axis, then it will be 1, 0, 0, K. This is cool. This is look. This is how people try to remember it. But this has been removed from the O levels and DMAS 4024 syllabus. For the shear, if the shear factor is K, the invariant line is x-axis, and obviously in the shear you move parallel to the invariant line, and then it will be the 1 K01. If the shear factor is K and the invariant line is Y, and it is you have to move parallel to the y-axis, and then it will be 1, 0, K1. Both of these has been, this and this has been removed from your syllabus. That's why no need to remember them. Okay, statistics. The bar graphs, a bar chart makes numerical information easy to see by showing it in a pictorial form. The width of the bar has no significance. The length of each bar represents the quantity. In the pie diagram, the information is displayed using the sectors of a circle. In O levels, you know, frequently they ask you to find out the angle which a certain quantity will have on a pie chart. And sometimes the angle is given and you have to tell that quantity. Histograms, a histogram displays the frequency of either continuous or grouped discrete data in the form of bars. The bars are joined together. The bars can be varying width, and the frequency of the data is represented by the area of the bar and not the height. When class intervals are different, it is the area of the bar which represents the frequency, not the height. Instead of the frequency being plotted on the vertical axis, frequency density is plotted. Frequency density is equal to the frequency divided by the class width. The mean of a series of numbers is obtained by adding and the numbers and dividing the result by the number of numbers. We call it, and if you have group data, then you will have obviously the frequencies. Then the mean will be summation fx divided by summation f. And you have classes, then this x will mean the mid value. How you find the mid value? You add up the two boundaries of that class and you divide the sum with 2. Okay, where the summation fx means the sum of the products of f and x, and summation, this sign means summation number multiplied by frequency. Here the summation f means the sum of the frequency. Median, the median of a series of numbers is obtained by arranging the numbers in ascending order and then choosing the number in the middle. If there are two middle numbers, the median is the average or mean of these two numbers. Mod is the mod of a series of numbers is simply the number which occur most often. The number who has the highest frequency, that is the mod. Frequency tables are a frequency table shows a number such as a score or a mark against the frequency f or number of times that occurs. Cumulative frequency, the cumulative frequency is the total frequency up to a given point. The cumulative frequency curve is always in this shape. This is the graph of less than. A cumulative frequency curve shows the median at the 50th percentile. If you take half of the frequency and check where it is on the y-axis, go to the cumulative frequency, then check the value on the x-axis, that will be Q2 or the median. Okay, a cumulative frequency curve shows the median at a 50th percentile of the cumulative frequency. The value at the 25th percentile is known as the lower quartile, and that at the 75th percentile as the upper quartile. The lower quartile, which we call the Q1, that is 25% of the total frequency. Whatever that number is, look here on the y-axis, go to the graph, and when you cut the cumulative frequency, check what is the value on the x. For the upper quartile, we call it the Q3. That is the 75% of the total frequency. And this is basically 1/2 of the total frequency. This is 1/4 of the total frequency. And this is 3/4 of the total frequency. Okay. This is 1/2 of the total frequency. And this is 1/4 of the total frequency. And you check it on the y-axis, and then you go to the cumulative frequency. And when you cut the cumulative frequency curve, go down and check what is the x value. That is called the Q3, the upper quartile, lower. And a measure of the spread of dispersion of the data is given by the interquartile range, where the interquartile range is the upper quartile, which we call Q3 minus the Q1. Okay, so that is called the interquartile range. Probability is the study of the chance or the likelihood of an event happening. Probability of an event is equal to number of the favorable outcomes divided by the total number of equally likely outcomes. If the probability is equal to 0, it implies that the event is impossible. If the probability is equal to 1, it implies the event is certain to happen. All probabilities lies between 0 and 1. Probabilities are written using a fraction or decimals. Exclusive events. Two events are exclusive if they cannot occur at the same time. the OR rule. For exclusive events A and B, the probability of A or B will be equal to the probability of the A plus the probability of the B. Independent events. Two events are independent if the occurrence of one event is unaffected by the occurrence of the other. The AND rule. The probability of the A and B is probability of the A multiply the probability of the B, where the probability of the A is and the probability of the B. Okay. Then we have the tree diagram. A tree diagram is a diagram used to represent probabilities when two or more events are combined. Symmetry. A line of symmetry divides a two-dimensional shape into two congruent identical shapes. So this is very important. When you draw the line of symmetry, the line will cut that figure into two equal parts. And when you will fold that figure along that line of symmetry, both the parts will be exactly, they will exactly match over each other. A plane of symmetry divides a three-dimensional shape into two congruent solid shapes. A two-dimensional shape has rotational symmetry if, when rotated about a central point, it fits its outline. The number of times it fits its outline during a complete revolution is called the order of rotational symmetry. For example, this is a very important table. Remember this table. Square has four number of lines, and its order of rotational symmetry is 4. Rectangle has two lines of symmetry, and its order of rotational symmetry is 2. Parallelogram has no line of symmetry, and its order of rotational symmetry is 2. Rhombus has two lines of symmetry, and its order of rotational symmetry is 2. Trapezium has no line of symmetry, and its order of rotational symmetry is 1. 1 means 0. Kite has one line of symmetry, which is along its longer diagonal, and the order of rotational symmetry is 1, which means there is no rotational symmetry. Equilateral triangle has 3 lines of symmetry, and its order of rotational symmetry is 3. Regular hexagon has 6 lines of symmetry, and its order of rotational symmetry is 6. Okay, so here we have trigonometry terminology. So this is called an arc. This is called, when you have these two radius, this is minor sector. This is called the major sector. This angle is the angle subtended by the minor sector at the center. And this angle here, this is the angle subtended by the major sector at the center. This is the angle subtended by this arc at the center. This is the minor arc, and this will be the angle subtended by the major arc at the center. If you draw a chord, the circle will be divided into 2 parts. Each part is called a segment. So this is a minor segment, and this is called the major segment. Okay, so let me increase the size so you can see them more clearly. This was what it was all about. Okay, then we have this shape, and in this shape you can see, let me show you. Remember this shape, this is the center, this is the radius, this is the angle subtended by this minor arc theta. The arc length, this arc length will be equals to theta by 360 2 pi r. This arc length is, sorry, this arc length will be, this arc length, I mean, this arc length will be theta by 362 pi r. The area of the sector will be, the area of this sector will be theta by 360 pi r square. The perimeter of the sector is this radius plus this arc, and that will be theta by 362 pi r plus 2 radius. Perimeter of the sector is this radius plus this arc. Obviously, this arc is theta by 362 pi r. Okay, then we have, okay, so we are done with this. My dear students, this was an effort to revise the Cambridge O-Levels Mathematics Syllabus D Maths 4042. some main concepts and their formulae. So I hope this video will help you, and it will help you to revise your, your syllabus content. You see, in mathematics, the actual thing is you practice the thing, you solve the questions. But this document you can use it to just have an overview of that, if you know all these concepts. Okay, so actually you understand the concepts when you practice the questions. This document is only for revision. So my dear students, I have tried my best to explain you these concepts. This document is not created by me. I don't know who has created this document, but whoever has created this document, we are thankful to that teacher. This is the courtesy of that teacher. We have this PDF file, and I don't know who created it. So if you find this video useful, if you find this video interesting, please share the link of this video with your friends, with your junior students, with your teachers, and please like this video. Also subscribe my channel. When you do this, it helps me to promote my channel. It's a great blessing for me that I can make these videos and I can touch the life of so many students around the globe and make their life little easier. Thank you very much and have a good day.